Hello and welcome to the Nova Show. I'm your host. Hello and welcome. Nova, welcome to the show. Here at the Nova Show, we do what I want. Fucking show. How's it going? Welcome to the Nova Show. I know it was a very long intro. I've been. Oh, the mic needs to be like. Check 1, 2. Is that better? Let's try this again. Hello and welcome to the Nova Show. I'm your host, Chris Nova. Welcome to the show. Here at the Nova Show, we do what I want when I want because it's my fucking show. Welcome to the show, everyone. How's it going? How's it going? So my OBS totally crapped out on me. If you can't tell, everything's all kind of weird right now. So I'm just tinkering with a few things here locally, and then we'll switch over to the show here in a second. Also, I don't know if y'all notice my hair looks super gray right now. I put like this dry shampoo in my hair and it like turned my hair gray. I kind of like it. I think I'm gonna stick with it. I kind of like the old lady look. So let's see. There we go. So we're gonna have a bit of a long intro here while I get my OBS dialed in. I hope y'all are okay with this. Let's see. Cool. There we go. Okay. So OBS looks better. It's still not perfect, but it's better. And looks like I have music dialed down. And let's see if I can't cut over to my side camera. Perfect. Okay. Hi everyone. Welcome to the show. How's it going? It's good to see you all. I'm your host, Chris Nova. Welcome in. Today on the show, we're going to be doing... we're going to be working on a tool called TCPjack. We're going to be hanging out with the C programming language today. Who here is ready to write some C? Twitch figured out what they can push ads in the middle of a stream for 30 seconds while muting the audio. Fuck the what? It's all good. I'm definitely not saying anything worth paying attention to anyway. Oh. Ooh. Trying to get my desk to come down. This is my one gripe with these secret lab chairs. These armrests are like really big. And I think you can like take them off somehow. Oh, you can lower it. There we go. Oh, there we go. Much better. Okay. Just kidding. I have no gripes with the chair now. Ayo, Nova, what it do? Hey, Coding with Strangers, how's life? Oh, what it do on my end? Nothing. I have nothing important to say. I try to do good things. I fail. I'm trying to do good things. I'm trying to do good work, but it's not easy. LOL stream content. Nova fixes chairs. Pretty much, yeah. So who else is here? Let's tell people hi. We have, it looks like a lot of people here. So B Santana, Scalper, started off strong, coming in hot with a loud boah. Faf in a Boot says, howdy, Nova. Coding with Stranger says, Ayo. I like that. Fohammer says, hey, friends. Dead Pie Fly says, hey, foe. Ghost11411 says, man, he's on escalator. It's going upstairs to see you later. I don't even know. Coding says, no, you gained some experience. Upgrade your interview skills for the next battle. Hex Digest is here. Mihai is here. Rick Cock. Oh my god. Rick Koch? Rick Cock. Rick Cock is here. Something is wrong with the mic. Loud music, quiet Nova. Perfect. People are commenting on my audio. Cody with Stranger says, just got my LLC done and trademark secure, so I'm hype. Nice. Congrats on the LLC and the trademark. Those are... It's an interesting and exciting process to go through. If you've never done it before, it's definitely a thing that can make you feel really good when somehow also make you feel really bad. It's a fascinating dichotomy. Thank you for the follow, Duke454. And Faff in a Boot says, love the gray. You know, that reminds me of that scene in Silence of the Lambs when Hannibal Lecter, like, he's got like the face mask on and he's like in front of the senator. They like drag him out of the prison and he's like, Senator, I love your suit, right? Like, and she's like, take this thing back to Baltimore, right? Like, that's how I feel about the love the gray, Nova. Like, it's like very much like complimenting somebody on their gray hair is strange. Speaking of this, when I was rock climbing, one of my friends commented on my gray hair. They were like, did you dye your hair? And I was like, no, I'm just old. That's all. And now I've got dry shampoo in my hair that makes me look even more old. So if you haven't been following along, welcome to the show. Sit right down, pour yourself a cup of coffee. I'm going to welcome you in. So I've taken a small hiatus. I stopped streaming. I stopped coding. I took a break, and then I took a longer break, and then the internet freaked the fuck out on me for like an afternoon, and then I said enough's enough. I'm gonna go and kill my ego. So I went and did that. We can gloss over a lot of the details there. They're not important. What is important, the takeaway here, is that I feel better, I'm happy, and I am a strong advocate for getting the fuck off social media. It has helped tremendously with my self-esteem, my general ability to govern and manage myself, my ability to sleep, and has generally brought an increase of positivity and joy and happiness, tranquility and calmness to my life. So that's the takeaway, and it's worked for me. I don't know if it'll work for you, but your mileage may vary. So anyway, we're going to be looking at some stuff in the kernel today, so I hope y'all are ready to learn about layer 2 networking and layer 3, and we're going to be looking at some implementation details around how Traceroute works, and we're going to be writing our own tracing mechanism in C, just for funsies. There's a small chance I might get to use this research and this work at my day job, but realistically, maybe not. I don't know, maybe we will. With the way things are going this year, who fucking knows if we'll be able to use it. So, one of the consequences of not having social media is I don't have a place to share my writing. So I wrote something recently, and I was wondering if I could ask all of you in the Twitch audience to do me a favor. What's that you say? Oh, you would love to help me out. Oh, fantastically. Okay, so here's what we got. Let me adjust my microphone here. So what we got that I'm going to ask y'all to help me out with is I recently published a small bit of literature. I know how much you all love my writing because it makes so much sense to everyone who reads my fucking ramblings. We would love to help you out, says Madeline. What up, Madeline? I feel like you and I go so far back, I just want to I want to have like a cool like friends only name for you. Like, what's up, Mads? How's it going? Also, Madeline, I read your email, but I have ADHD, so I haven't responded to your email. But I read it and I thought about what I would type. I was just on my phone and I didn't have like the ability to type a structured email on my phone in the amount of time my ADHD little window of interest would allow me to. Take your time. It took me like 2 months to send it to you. Honestly, I could not ask for a better like friend relationship than that right now. Like I would love to just go back to the like I'll send you an email in the next 60 business days style like pen pal relationship. It's actually probably a lot better for our mental health, to be honest. But you can rest assured when I send you an email back, it will be a glowing biblical level of detail with all kinds of updates and just all kinds of exciting responses for you. Point is, I'm proud of you, and I see you out there doing good things, which is awesome. Okay, so here's what happened. Let's mix it up a bit. So I wrote this blog. Who here has seen this blog before? Show of hands. Who here knows what the fuck we're looking at? Who here has seen this before? I don't think anybody's going to raise their hand. And that's okay. So Mihai says Mihai follows me on Discord. So Mihai seen this, it says, just finished reading it. So my ask here is that if you're following along, you at the very least skim this. So everything we're going to be talking about today is kind of written in here. And this also kind of covers the past 2 streams of what we've talked about on my show. So if you're here and you want to learn about kernel tracing and you want to learn about my goofy idea to instrument the network, and you want to know what we've been doing in C, this gives you the context and everything you'll need to know. So what does it say? It says, basically recently I've been trying to make GitHub faster, and I've been doing a lot of kernel instrumentation. So if you're not familiar with what kernel instrumentation is, it's this idea that you can write little functions in your code base and they'll execute when you do certain things in your kernel, and those you can make those functions do kind of like whatever you want. There's a really good analogy out there. I forget who said it. Somebody smarter than I am said kernel instrumentation with eBPF is like JavaScript for the kernel. And I deeply agree with that, right? It's the same way JavaScript is to like HTML. It allows you to like do cool things in HTML. eBPF allows you to do this in the kernel. Yes, please. Didn't know this category in Twitch exists. Bless you. Tangential question, but how did you make those diagrams? Great question. And if you scroll to the bottom of my blog, I have it answered already for you. You scroll all the way down to the bottom, right here in the fine print, there's just 2 sentences, and it should be, I'm trying to keep my blog very minimalist. It should be exactly what you're looking for, because I had the foresight to predict that people would be asking this question. And it says right here, ASCII diagrams are drawn with ASCII flow. And look, there's a link, and it says and rendered with SVG with GOAT, and there's a link. And so basically these are just ASCII diagrams, and that's how they're drawn and rendered on the page. And it looks beautiful, I'm not gonna lie. I love the simplicity of my blog. I will write so many technical things on this blog because it just looks so fucking good to read. Okay, so anyway, so I did some kernel instrumentation. It was like the JavaScript for the kernel. You can do all this like arbitrary stuff. And I was like, that's really effective. This is a good idea. I like this idea. And I said to myself, and I said, self, it's me, Chris Nova. I said, self, I wonder if we could instrument other things. Not other parts of the kernel, but just other things in general. And so I started to kind of wonder, would it be possible to instrument the network itself? Were there things that I could learn from sending packets out in the network that would actually give me some insight into how things were doing on the network and start to visualize the network? And I thought, maybe there's something to this, and maybe I would be able to adopt a similar philosophy that I used with eBPF, but just with instrumenting the network. So anyway, I thought about this a lot during my vacation. I thought about this a lot. So I came back home from my vacation, from rock climbing in the desert and then rock climbing in the valley. And I turned on Twitch and I said, fuck it. I don't care what people have to say. I'm going to go do my nerd stuff and I'm going to live my best life, and that's okay. So I said, let's start looking at tracing TCP requests. And I started to look at this thing called Traceroute. And this is kind of where we're going to get into today. So Traceroute works. Basically what it does is it can either send a UDP or an ICMP or a TCP send packet out to a destination on the network, and it sets this flag known as TTL, or time to live, and it just basically increments the TTL flag every time per packet until it reaches its destination. So that's how it works. And it starts at 1. So imagine if we were sending a TCP packet from a client on my computer to, let's say, google.com, and I set my TTL equal to 1. And then it would come to this router alpha here. And this router alpha would be its first hop in the path, and it would decrement TTL, and TTL would be 0, and it would drop the packet. And then we set TTL is equal to 2, which this is what's actually drawn in the diagram. And we say, okay, so it'll go to 2, so it goes to the first router, and it says, okay, so we have 1 hop left. We've decremented by 1. We have 1 more to go. And we send it to the second router, router beta. And now TTL is equal to 0, and we drop the packet right there. And if we set TTL to 3, you can rest assured it would come over here to Charlie. And if we set TTL equal to 4 or higher, it would make it all the way to the destination, assuming that the destination was 4 hops away. So we all understand what TTL is for. So the higher your TTL, the more hops you can traverse before the packet is dropped. By default, most TTL is set to something along the lines of 64. However, what Traceroute does is Traceroute will set it to 1, and then it'll wait and set it to 2, and then it'll set it to 3, and then set it to 4. And what happens is eventually we get a response. And that's what we're going to be coding today in C, is we're going to be snooping these responses off the wire. So these responses come in the form of basically ping packets, of ICMP packets, and the router is smart enough to embed its identity in the response packet. So by reassembling the response packets back at the client, we can actually map the route that is taken. So this is how Traceroute works today. And most network engineers know this. This isn't anything new. This has been around since before I've been working in this field. You know, this is older than most people watching the show right now. So anyway, that's how Traceroute works. Now there's some shortcomings with Traceroute. This is a good model and it accomplishes what you want it to do, but there are basically some shortcomings, right? And so those are called out here. So, you know, what happens if we miss one of these ICMP requests or the router doesn't send it like it's supposed to, right? That's where you get these little asterisks in a traceroute command. So if you were to go and you were to, you know, traceroute, or actually here, let's SSH novix at alice.nova.network. There you go. So traceroute, you know, google.com. sy trace. So if you get it, you can see this is a traceroute from a public server over to google.com. You can see that we're actually able to get the name of, this is like the ISP router that we're able to get back. Okay, but in some cases the ICMP message is dropped and we're not able to get any data back. What's exciting about this is we can actually get the latency in milliseconds for each hop. So you can actually see where in the network your shit slows down, which is cool. And again, most people know this. So another shortcoming of Traceroute is that there's no guarantee that the path taken for each of this process is the same path that we'll take. So in theory, I could issue this traceroute command again, and you see in this example, it goes up to 10. There's 10 records here, but there's only 8 records here. And that's because we actually traversed a different path to get to google.com. And there's an unlimited number of paths that you can take on the internet, and there's no guarantee that your packets will actually traverse the same path. See, we just went from 10 back to 8. So every one of these trace routes, we're actually probing a different network path. And so this is an exciting part of how networking works across the internet. Most people know this. This is where the web originally came from, was we had a web of nodes and you bounce around all of them all the time. So anyway, because of this no guarantee that the path taken for each iteration of the process is the same path that will be traversed during a future transmission, which I just demonstrated, it could take an entirely unique path each time. Okay. So we also know that we can measure latency. And how do we measure latency? Well, we measure latency because we can actually time the time it takes from when we send a packet to when we receive a response. So if we look at our diagram, we can timestamp each time we send one of these TCP packets, and we can timestamp whenever we get one of these ICMP responses. And we can sort them based off of how long they took, and the longer they take, the further away the hop is, presumably. And that's how we trace a path. So that's how Traceroute works. Okay? And so I said to myself, well, this is cool, but I think we can do better. I think we can do more. And one of the big shortcomings of Traceroute is that when you traceroute something, you put in a host. So you do traceroute google.com, which means it will basically establish a brand new connection and everything there to go find google.com. So it's a new connection each time. What this doesn't do is it doesn't tell you the route that any existing connections are open to. So for example, I am SSH'd into the server called Alice, which means there's a connection from my computer that I'm streaming from over to the rack behind me, and that connection has remained open. In fact, if I was to open up another terminal and go to source TCPjack, remember TCPjack is the tool that we're building, and I was to compile this, I could run tcpjack.l and list all of my open connections on my computer right now, and you're going to see some of these are going to look pretty familiar because I'm web streaming right now. Okay, so we have OBS, we have Firebot, which is my JavaScript bot I use for my chat automation here on Twitch. We have Discord, because I have Discord open. We all know I got to be listening to my Spotify music. We have Brave, which is the browser I use to explore the internet, etc., etc. And if we look closely, we can see, aha, here is my SSH tunnel, going from my local computer over to this public IP address, which is the public IP behind me. So we can grab this value here, which is an inode on Linux, and I can actually do a TCPjack J, and then I'll pass in the inode, and we'll actually get a permission denied because of the technique that I'm employing here, or sorry, not employing, using here. Is this TCP hijacking technique that I'll go into detail in a moment on how this works. But I'm basically going to steal this connection. And so we run this as sudo, and it should just hang. We got an error. Let's see. Did I already kill the connection? No. Let's go find another connection. Let's see. Let's see if we can't find another one. So here's SSH. Here's our inode. And I don't see any other SSH in here. So let's try this again. And let's see what we get. I wonder what Linux error code 9 is. I'm not spitting out the enum value of the error code right now. Let's see. 9 is bad file number. Oh. I bet it's... I don't know. We'll have to debug it. Point is, we're going to be digging into it in the show. And we can also do it by PID as well, which I'll have to code that throughout the show today. But the point is that we can start to explore what it would be like to actually go and instrument one of these connections and try to figure out the hops that it's taking to get there for every packet in an established TCP connection. There's not a way to do this today, as far as I know. There might be some tools like TCP Traceroute that do it, but I want to get pretty crisp about what we're able to do. So I actually think we're going to try to get this specific example working today, to be honest. That's a good example that I would love to dig into. So that's what we'll work on today on the show. And then let's talk about this PID, or sorry, not PID, TCP file descriptor hijacking, because you're going to need to know this as we get into the C code in just a moment. Basically, if I was to summarize, I'm able to steal file descriptors from one process to another. This used to be very involved in the kernel, but not so much anymore because of this avenue that I kind of show you here. And it talks about these new system calls. There's this one called pidfd, getfd, and here's the actual kernel code for it, the patch. And this talks about the history of how it came to be, and basically how it works is it uses ptrace to pause a process, and then once the process is paused, we use this SCM rights, which comes from the Unix part of this system, and we're able to actually exchange the file descriptor from one process to another. Here's an example implementation that I wrote in C that allows you to go in and pass in an inode and basically steal the file descriptor here on this line from the process that you're targeting, as long as you have permission to do so. And once you have that file descriptor, you can use it arbitrarily. So as long as you know what the file descriptor is for, you can use it for with any of the other Linux APIs for it that you want, which basically means I'm able to instrument established TCP connections and come up with a model that looks a little something like this diagram here, where we can find TCP connections that already exist, and we can come in and we can actually see the path that they're likely taking. Now, there is a good chance that these existing connections are going to shift around and move over time. This is why the TCP protocol exists in the first place. However, we can be fairly confident in most modern day infrastructure that once a connection is established, its variation is going to be negligible. So the hope would be, given an established TCP connection, we can start to figure out exactly what the commonly used hops are, and we'll be able to attribute that back to a PID in the first place. So here's a demo that if we wanted to do this demo really quick, the code is working up until this point, and this shows you how you're able to start a netcat server, and you're able to start a netcat. Actually, here, I'll just do it. I'll just fucking do it. Why not? Okay, so let's do this. So we'll start a netcat server, and we'll listen on port Nova or 9074. We'll open up another terminal, and we'll connect to that server, and we'll do that by saying incat localhost on 9074. And what's cool is now that this is open, I can say from client, and I'll echo, and if we go back to the other one, you can see that it's basically been echoed from the client. And that's just a very simple way. These are two different terminals. If you watch up here, you'll see them changing, right? These are two different terminals. It's a very simple way to send data from a client to a server. So, you know, example, sending from client, enter, and then we go back to the server, and you can see we basically are mirroring the command here on the server. Now, what's cool is if we close this, we can do TCPjack -L. We can find our incat process using this list command that I coded the other day on Twitch, and we can actually start to find these connections. So here's this one. So this one is going from 9074 backwards. So this is the reverse connection. This is not the connection we're looking for. We want to find this one. This one is going to 9074. See how the arrow is telling you which direction it's going? So we'll grab this inode, and we should be able to TCPjack this inode and run it as sudo. Huh. We're still getting bad file descriptors. Maybe there's an off by one error? Let's see. Maybe we just found a bug. I'm not really sure. Let's see. Here's incat going to 9074. I don't think this is a different inode. Yeah, we're still getting this bad file number. I don't know why we're getting a bad file number. So let's dig into it and find out. Anyway, that should be able to steal the PID, and we have a bug, so we'll go fix it and we'll figure it out. Cool. So first things first, let's kill all of my terminals. And we'll go to TCPjack, and let's make sure I have all of my code. And we'll open up my IDE here. So we're doing TCPjack-J. So we're here in TCPjack-C and .c, and we're looking at this -J section of the code here. And we were getting, what was our error we were getting? error hijacking file descriptor for established TCP connection. Error code 9. So we're hitting this error and we're getting our error node 9. So FD from inode is failing. Let's go see. FD from inode is failing. Let's make and this. So let's just get one we can experiment with. So let's pick one we can tinker with here. We'll use the Spotify one. What do y'all think? I was able to kill Spotify the other day just by doing this. I was able to steal the Spotify streaming socket, and I accidentally sent like the string boops over the socket, and the server dropped my connection. Because you know that the Spotify server was definitely not expecting BOOPS to come over their WebSocket. Anyway, let's go see. So we have this function. And we can run make and sudo dash e TCPjack j and then the name of the Spotify inode like that. There we go. And we get our code error here. So let's start off and we'll print f. We'll say inode is equal to D with a new line, and this will be inode, and I gotta move this microphone, sorry guys. Mic check, there we go. Okay, it's back. Yeah, when I moved my mic, I think I accidentally knocked the USB loose. So anyway, I think I had last night coded this FD from inode, proc entry from inode. I think this calls FD from inode twice, which is the problem. So in here, I bet we have an FD from inode. We do. Which means in our TCPjack, we actually don't need this. We'll say int fd is equal to proc entry. It's already here. Jacked fd is what we want. Let's give this a go. There we go. Cool, so it's working now. So let's get rid of our debug. And this was an FD from inode, so here. So let's try the SSH command now. This is actually exciting. I want to git add, git commit, SSM, we'll say fixing inode bug for -j, git push, origin main. So if you want to see, guys, I have an interview on Friday for a full stack dev position final round. Fuck yeah, do it, do it, do it. Congratulations. So if you want to go drop my project a star on GitHub, you know, our bonuses at work are directly related to how many GitHub stars that are open source. I'm just kidding. That's not true. It'd be cool if it was, because I would be getting way more money than I'm getting right now. But these stars actually mean nothing, as it turns out. other than just make you feel good, which candidly I absolutely love. So here's the repo. So I just pushed to this here. So we're able to see a lot of what GitHub is doing on the back end, and you can, or not GitHub, a lot of what TCPjack is doing on the back end, behind the scenes, if you want to come in and explore the source code here. And you can see this is the code that I'm working on, and here's my most recent commit. And the name of this project is TCPjack. So, and here's the little demo from my blog as well. So anyway, let's get this SSH connection back up and running. So here's Alice. So I'll just do Alice here. And so here we should be able to TCPjack L. Oof. Let's try this again. Make TCPjack.l. There we go, without all of my debug. So we want this SSH command here. So we want this inode. So we should be able to jack this inode. Sweet. So the question is, can I type in my terminal from TCPjack here? This will be cool if it actually, I'm super fucking curious. If this works, I'm going to be really, really fucking impressed. So let's try list. Okay, so good news. It didn't send anything over the actual connection, which is not the worst thing in the world. We could also do echo ls to this. Okay, so look, it actually broke the SSH connection. The cipher is missing, says Kablito. Yeah. So I think we need, it's encrypted because it's over SSH, so I don't think it's just going to blindly accept connections because it's a layer of encryption encapsulation away. I was hoping that it would no longer encrypt our commands, but alas, SSH is far more clever than we thought it was. But it would have been exciting, to say the least. So anyway, we can reopen SSH, and I suspect there's a way we could like encrypt a message with my private key and then send it over, and it would probably work. But for right now, this is a good example of what we're doing. So what we're going to be working on today is this TCP-T for trace command. So I want to be able to do a layer 3 trace by inode, meaning we're going to be using TCP to trace based off of the given established connection. So this is why I went into all that detail earlier about how Traceroute works, because this is effectively what we're going to be doing here in my local code base. So we have this trace.c, and what we're going to be doing is we're going to be working in this function, this emit trace packets function. We're also going to be working here in this assemble trace. So we're going to have to use libpcap to read the ICMP responses off the wire. But first, we're going to take a quick break. So I'll see everyone in just a few minutes. and we're back. So we believe we have to do some plumbing here, and we also have to do some libpcap here. Does anybody have any preference? Do you want to do some semantic C plumbing, meaning we have to like change some of like the command line structure of TCPjack in C, or we can get right down and dirty with libpcap right away? They'll both take about the same amount of time, and that'll probably be all the time I have because I have to go upstairs and cook dinner for my absolutely bombshell hot ass wife that is upstairs. I love flirting with her. So there's a good chance she's watching the show right now. We'll see. Anyway, no opinions, huh, chat? After all of this, you've been here, you've listened to me rant for the past hour about tracing and TCPjack and the C programming language and connections and inodes, and nobody has a single opinion. Okay, we're gonna do the boring stuff, and I'll save pcap for tonight after dinner when we're all snuggling on the couch. Mihai says go hardcore. All right, we'll do the plumbing, and then we'll get into the other stuff. I think the plumbing will be quick. It should be anyway. So the problem here is that we're not surfacing our connection. So what I think I want to do is I want to go look at our API. And we have hops, we have TCP list, we have these things called cons. TCP con, it's got a proc entry, and each proc entry has a jacked file descriptor. I actually add comment here. The jacked FD is a one-to-many mapping of socket file descriptors to a given PID. Period. If this is parsed via an inode, it is a specific FD. If this is parsed via a PID, it is the first one found at runtime. Okay, so I think all we really want to do is we want to get the connection to be our common. This is our user ID, local address, local port, remote port, proc entry. We want this connection to be our main thing we pass around. So basically, what we want is we want a proc entry from inode. I think we want a from trace inode. So I think we want to basically change this from proc entry from inode to TCP con from inode. And I guess we're actually going to do this. We're going to add two more functions. We're going to code two functions really quick. So this is going to be this one. Here we go. We'll do this. So this is going to be we'll call this con TCP con from inode. And this will be TCP on from PID. And this will, whoop, that one stays. And then we'll move these down. And then this is going to be TCP con. Boom. Boom. So there we go. Cool. So TCP con from inode, TCP con from PID. We'll copy these from our header file and put them in proc.c. And we will come all the way down here and we will paste and we will write our implementation here. Beautiful. Lovely, lovely, lovely. So show of hands, who here has watched me write Rust on the show before? I was talking to my partner Q about this last night. I want to get y'all's take on the matter too. Who here has seen me write Rust? Who here has seen me write Rust on the show? Cheeto Bandito says, hey guys. So my question is, do we think that just no bullshit, total candid response, speak from the heart, do I write C or Rust more fluently? My partner and I have different opinions on this, and I think she knows me the best, so I'm curious what people who actually watch me code think, because I think I write them the same, and I think she's like, you change depending on the day of the week. And I've heard people say that my Rust is garbage, and I've heard people say my C is garbage. I think actually my C is pretty garbage. I think all my code's garbage, let's be real. Okay, so anyway, so this is TCPcon from PED. And so really what we're gonna do here is we're gonna grab, I don't know Rust well enough to judge, I can read your C. Okay. So proc entry from inode. So we will basically steal this function, I believe. And then this calls proc entry from PID. So the question is, how are we going to get... I guess we're going to have to read the TCP... You know what we're going to have to do? Where is... proc entry from PID? No, we want... file descriptor from inode. File descriptor from PID. Where is my... It's list.c. You slimy bastard. This is what I want here. So here we have TCP list. So in theory, we could I don't want to have to list all of these just to find the... I would have a hard time comparing fluency in C versus Rust because they mean different things because Rust is such a dense language. That's very true. I think it was more of a comment on how comfortable I am as a public presenter with either of these. How competent I am. So I think what we want to do is we want to open this up. And we're going to steal... this much code. We're going to steal all of that from TCP list. We're going to move it into proc. It's going to go right here. So we'll do TCP con from inode first. So we read proc net TCP. Line nums, numcons. I don't think we need this. So we gloss over the first line. We'll add a line num there. So we basically read all of this from, and then we do our compare here. So basically we say this is coming from inode. So we'll say if, we'll call this search inode. We'll say if search inode is equal to inode. we return con. There. Most of the stream is way beyond my meager dev skills, but it's always interesting and I always learn something. Also, don't lie, you love hanging out with us in our cool community. That's really why everyone's here, is because we're a bunch of really nerdy, awesome dorks. So. Dorks, says Carl Bright. That's right. So here's TCPcon from inode. And then otherwise we are going to return, where's our TCPcon? Bro, where are you at? So we'll say return struct TCPcon. I have to do it this way, don't I? Struct TCPcon is equal to this. Go. Cool, and we will copy this whole implementation. I know, it's a lot to copy and we can maybe clean it up later, but for right now, you all know my philosophy. Make it work. Search pid. So basically we say search pid is equal to pid. Ooh, have we not gotten the pid out of here? I thought there for sure was a pid in our API. Am I crazy? Is there not a pid? Connection state. Oh, this is gonna be difficult. So we need the inode of a file descriptor we could do. Or do we just take this out? Let's just take this out for right now. We'll just simplify our code. I was trying to go above and beyond, but that's just going to introduce too many problems. So we'll go TCPjack.reach. So we'll only do this from inode. Cool, so let's go back to our proc.c. Oh, we're getting raided from Lana. What's up, Lana? Thank you for the raid, everybody. Check out my homegirl, Lana. She's badass. She is my sister from another mister, and I love her. How was your show? Were you still working on Strain? How's it going? Shout out given to Lana. Thank you for the raid. You know it. That's awesome. I haven't looked at it, the video game in a while. How's it coming along? Last time I looked, you were working on commercials. So I don't know if that was good or bad or a long time ago or a short time ago. How are you doing? I'm good. I'm good. I'm working at GitHub and... Oh, so everybody who is not Lana, put your earmuffs on. Lana, because you're here. So I proposed to Q recently, so we're gonna get married officially. So that was really exciting. I figured you would be happy for us. Good, it's not a big overhaul putting it all back together. Oh my god, congrats. Thank you, thank you. So that was cool. So that's been a big update. Other than that, we're just chilling, hanging out with life on the West Coast. So anyway, welcome to the show. And if you're new to the show, welcome. If you've been here before, welcome back. If you don't know what you are, welcome to the party. I'm your host, Chris Nova. Welcome in. Here at the Nova Show, we do what I want when I want because it's my fucking show. Today on the Nova Show, we are working on a new TCP instrumentation tool called TCPjack. Hopefully it will help with some of my work that I'm performing at GitHub, trying to make GitHub faster. So if you use GitHub and it's slow, maybe my work will be useful one day. We'll see. I hope it is. I'm going to try really hard for it to be useful. So that's kind of what I'm working on. Right now I'm just doing some research and working on an ancillary open source tool that I started a couple of weeks ago called TCPjack that allows you to hijack TCP connections and do tracing latency performance analysis on the network. So that's what we got going on. So I'm going to get back to focusing. If you're a friend of Lana's, you're a friend of mine. Lana, if you've been streaming all day, I suspect you're tired and probably going to go get food or drinks or do whatever you're going to do. So everyone, if you're new here, make yourself comfortable. You're amongst quality, nerdy people, and we're going to get back to working in the C programming language. Okay, so we were working on getting a TCP con from an inode on the file system. Thank you for the follow, everyone. I do appreciate it. Thank you, thank you, thank you. And so the one thing that we don't have here that we do want... Oh, we do have proc entry. Oh, we do call proc entry from inode. Just kidding. So this is pretty much done then. Wow, that code was surprisingly straightforward. So we want to get a TCP connection for a trace. So let's go find our trace for -t here. So we basically want to change this to TCP con, change this to TCP con, and this is going to be really boring, TCP con from inode. There you go. We'll say if TCP con proc entry .pid is equal to 0, error. And then we'll say trace proc entry, which is here. Which really we want to pass in a connection. So this is the thing that I was really freaking out about. So we have trace proc entry and we also have trace PID. How do we get the inode of a file descriptor? We need to get the TCP connection of a PID. I'm going to turn trace PID off for right now. And we're just going to have trace inode. I know what everybody's saying. I know what you're thinking. But Nova, you had trace PID, and I will get there again in the future. PID of a TCP connection probably isn't possible directly, is it? So this depends on how we get the socket file descriptor from the proc table, but yes, we can associate one TCP connection back to a process that's controlling it. And so basically, if you look, there's like a, in the API here, there's like I forget where it is. There's a jacked FD comment here. This is, I think line 56 is what you're looking for. If this is parsed by a PID, it's the first one found at runtime. If that makes sense. So we have, sorry, I was losing my train of thought here. So we want to get rid of the trace report. No, we want to do trace PID here. We'll select the first socket in proc. So let's just do this, actually. We'll just turn this off for right now. So there is my little comment, which is fine because we're not using it for this flag we're coding right now. So we want to do trace proc entry. And we actually want to change this to trace TCP con. and this will be TCPcon, TCPcon there, and it will send spoof packets across an established TCP connection. Perfect. And this is TCP. What do you think if I want to learn Rust as my first programming language? I mean, let me put it this way. Rust was like my 12th programming language, and I still hated it. I mean, I think Rust is my favorite programming language, don't get me wrong, but like, it's, I don't know. I'm writing C. Don't ask me right now. I'm distracted. Ask somebody in the chat. Go ask your dad. So we want to change trace inode to TCPcon from inode. And then basically we change this to TCPcon to TCPcon. No, lowercase. And TCPcon. There we go. And this is trace proc entry. We need to rename this. Hold on. Trace TCP. There's that. And go back to our API. We have trace inode, trace PID. Here we go. And trace TCPcon. And this will take a TCPcon, and we'll call you TCPcon. Cool. So we have trace.c, trace inode, we have trace TCPcon. Trace inode gets the TCPcon, passes there, and then TCPjack.c does trace TCPcon and TCPcon. Wham, kablam, thank you, sir. Print trace report, cool. Who thinks we're gonna get a hole in one? We did not. We have a proc entry error on, let's see, TCPjack line 145. Aha, so this is -p PID. I'm just gonna get... We're just gonna remove this for right now. Proc entry on trace.74. So here, TPS report. Trace report has PID, inode, proc entry, num hops. So this is tcpcon.proc entry now. And we have dot PID is equal to tcpcon dot proc entry dot PID. And let's format this code. There we go. What else do we have? We have dot inode will be tcpcon dot proc entry dot jacked f. No. It's an inode. So on dot inode. And what else do we have? We have dot numhop. We haven't built any of that yet. Okay, so that's fine. Format our code. There we go. And so now we should be able to pass our trace emission context, should be able to get tcpcon.procentry. Should now have jacked FD. Let's just add the whole fucking TCPcon to it. What do y'all think? So here, you'll just get a struct TCPcon. We'll just call you con. Hey, and we will put you right here. .con is equal to TCP. Send it to our P thread. Create, and then we need to pull our sock adder in. Good old satter datter here. So where's our API? So we have trace report, TCPcon. We have in adder, and we need sock adder. We need a socket address. So how do we get a socket address in C? So this is a in adder, I believe. Yes. So we need to convert a in adder to sock adder, and we have the port as well. Let's go do this. So let's see what we have here. So this has got a sock adder and then an in adder. Oh, so I can just define it literally, can't I? So I bet I could do socket in adder. So this will be TCPcon context.con dot, so SN is the socket in adder, so source adder. So this will be the local, because we're going out, we're instrumenting outbound connections. So this will be local adder. Very good. Syn port will be context.con.local port. Beautiful. Get rid of that to do. Okay, and then you will be destination adder. So syn adder is equal to context con remote adder, and syn port is context.con dash remote port. Boom. All right, get rid of that bullshit. Okay, so make, who thinks I got a hole in one? Let's see, make, I did not. So proc entry on trace.c85. Where is 85? Printf TCPcon. Oh, tracing. So this will be tcpcon.proc entry. TCPcon. This. I mean, jacked FD and trace.c. Context.con proc entry jacked f. I like how it's called jacked FD. There's all these little Easter eggs in here in my code. Okay, so TCPjack now compiles. Okay, let's run our code and see what we got. Okay, so, oh, Benson, welcome to the party. I'm working on TCPjack, the same shit we've been talking about for days. Three things now, Benson. Number one, admire my beautiful C output. Number two, I have some days off this weekend and I'm going to Hood. If you want to do what you think I'm talking about, then you know what to do on my phone. And number three, look at how beautiful this other interface is. So if you run TCPjack list, it will list all of the available TCP connections on your system, and it will color code them. Isn't that? And in fact, if you just give me just a small second, just a quick here in list.c, we can do Pentry com. We can change this to 16. We can change this to 16, and we will just make, and there you go. Okay, so now it's nice and neat. Oh, we're still off by one. It's because of localhost, isn't it? Anyway, it's fine. This is gonna bother me, but that's okay. Anyway, so you can see now that if we do TCPjack-list, this is basically a netstat listing of all of the TCP connections on your system that you can hijack. Which is cool. This is exciting. I don't know. And then we can go steal these file descriptors now. Okay, so anyway, so that's TCPjack minus list. So let's grab one that we can steal. So we're gonna continue to fuck with this SSH connection here. So we will try to jack -J for jack. We'll try to jack this connection. And we have to run it as sudo because we're stealing the file descriptor via some privilege escalation-y things in the kernel. Is that PID0 talking to somebody on 443? It's not PID0, this is null. Basically, this is either a process that has died, or it's a thread that has no owner. Okay. Netstat has these as well. You'll see a handful of these in your Netstat connection. Okay, cool. So we have officially jacked the SSH connection at this point. So what we can do here is, now that the SSH connection has been jacked, we can let me think what we want to do. Let's try to trace it. Cool. So we actually killed it. So we'll try to trace. Well, we have to get a new one. Hold on. So let's try to find it again. Here's our new inode, and we will trace it. I have no idea what this is going to do. Cool. So we did send a packet 0 and it exited. I don't know why, but we can do some quick debug and see what we're doing. So we should be sending a sent packet 0 with a TTL of 32, which we know we only want a TTL of 1, so you definitely shouldn't write accounting software in JavaScript. I mean, thanks, I guess. What's a TTL? You can read all about TTLs here in this friendly blog I wrote that covers my post that I'm working on. Okay, so we sent a packet 1 over SSH. I bet it just killed. I bet the reason that this stopped right here is I bet it killed. Yeah. Okay. So this is fascinating. I mean, now that I say it out loud, I think none of us are going to be surprised at this behavior, but not surprising that sending a valid SYN packet across an established TCP connection to a destination with a high enough TTL causes the connection to break. Which, like, is cool because, like, I can break connections, but also, you know, probably not the safest for production instrumentation. So Benson wants me to flip the reset flag. I think we can flip the reset flag. I think that we have more options than that, actually. I bet there's a bunch of flags we can tinker with. I don't know how much we're gonna have to do into like the guessing and checking of this, of like setting the TTL1, doing like an in-map style, like, I bet it's a fucking SSH connection. Let's go check and make sure, right? Oh, I meant I expect the other end to be like, send, what the fuck, reset. Oh, so Benson was saying it's a reset coming from the server. See, I think we've got to be able to send a couple. So here's, you want to know my real thesis here? You want to know what I think we should do? I think we should calculate a bad checksum. Dan used keep alive packet. Yeah, so Dan used TCP keep alive packets. I think it's either a reset. So here are the four options basically. It's keep alive, it's reset, it's synac, or it's bad checksum, and some combination of the prior three. So I guess we have 6 total options. A bad checksum would be good. The reason I say bad checksum is because that's what we did with boopkit. Who remembers boopkit? It's an oldie, but it's a goodie. So boopkit was something I did for Ukraine post-invasion. And this works by setting a bad checksum in a TCP packet. See this bad checksum section here? And you can actually sneak a payload into that packet and the server will interpret it. The reason that we used bad checksum is because when you send bad checksum, the kernel drops it and triggers an eBPF trace point, which was our attack vector on the server. And that's how we were able to do remote command execution. But we're not trying to break into computers. We're trying to learn more about them because I'm getting paid to do this one for my day job, not trying to break into computers in this one. Just a subtle few lines of code of a difference, and it changes that quickly. The use comes from the fact that there are no alternatives for browsers. On the other hand, people are still talking about JavaScript. Let's go with keep alive. We're gonna go with keep alive. So we have packet TCP send TTL, and we're gonna copy this function as well. And so this is going to be packet TCP send keep alive TTL. So we'll grab this whole signature and we'll go all the way up to TCPjack.h. And we'll go here, here, here. Create a TCP send packet. A keep alive, I guess it's keep alive. Okay. With a custom TTL value, period. Period. Cool, so we'll go back to trace. So how do we form a keep alive packet with TCP now? I don't see a flag here for keep alive. I see the urgent pointer, I see ACK, I see push, reset, send, fin, ACK sequence, destination source, urgent pointer, source adder, destination adder, place adder, protocol, TCP header, psi, pseudogram, datagram, do some memory shenanigans, more memory shenanigans, calculate the checksum, and you're off to the races. I don't see fucking keep alive in here. Are y'all gonna make me go and read the fucking RFC? TCP RFC. I hate that one. You know you're getting old when you have an opinion on which rfc.org site you prefer to read from on your Twitch stream. Okay, so we want to look for keep alive. I don't even, is there TCP keep alive overview. In order to understand what a TCP keep alive is, we will just call it keep alive does. You should know nothing more than read the name. Keep TCP alive. When you set up a TCP connection, you associate a set of timers. Some of these timers deal with the keep alive procedure. Checking for dead peers. So is it just a synac packet? What the fuck is this? You send a peer keep alive probe packet with you send a keep alive probe packet. What the fuck is a keep alive probe packet with no data in it and the ACK flag turned on? Okay? You can do this because of the TCP IP specs as a short of duplicate ACK. So we're basically sending an ACK message and the remote endpoint will have no arguments as a TCP is a stream-oriented protocol. On the other hand, you'll receive a reply from a remote host, which is da-da-da-da-da, with no data in ACK set. So we can ignore that reply. If you receive a reply to your keep alive probe, you can assert that the connection is still up and running. So we basically just turn on the fucking ACK flag? Well, herpity derpity derpity derp. I guess we just call it TCP keep alive TTL like this. Is anybody else on the edge of their seat right now? This is so fun. Benson just wants to see me flip a bit and then go point it at SSH and see what SSH does. That's all that we're gonna do. Okay, so where's my fucking fuck here? Where'd you go? We'll just call it keep alive because it's just really an ACK packet, but whatever. Okay, so we have TCP trace.c. So you are now a keep alive packet. Okay, so here's the other thing. We want our TTL is equal to 0, basically. So this will be TTL. This is going to be context.count plus 1 is our TTL. No, it's not context.count plus 1. It's I plus 1. It's I plus 1. Oh, Nova Pants. You should know better, young lady. So, TTL is set to I plus 1. Okay. So there's that. And sent packet TTL is equal to I plus 1. Alright, so let's SSH into the server again. Let's find our SSH connection. Here it is. We'll grab our inode and we will trace our inode. We sent one packet and then the server dropped our request. Connection to Alice closed. Wow. Let's keep trying. What else are we forgetting in our send TCP keep alive packet? Is there a payload? Do we put any data at the end? So datagram, set MMS, that's datagram. TCP, so we calculate the checksum here, and I don't think we add anything to the end of the packet, do we? So here's the TCP packet and here's the IP packet. So the layer 3 packet is here. It's pseudogram. Do the same for the pseudo header. Enable SAC, enable MMS. Are only set in the send packet. So do we need to get rid of these for other send packets? Do I have Wireshark up? I mean, I have it like, I have TCP dump on the command line. I don't have it like on the network. I have it on my router. We can go turn it on my router if you want to see it. I don't think we need Wireshark. Where we're going, we don't need Wireshark. We can just do it the old-fashioned. I bet it's these. I bet we need to get rid of these. These options. Let's go see. So let me go pull up my old C code here. So we have boop. Thank you for the, what was that, a subscription or a follow? So we have create ACK packet. Yeah. So in order to create an ACK packet, we get rid of all of these. So after the mem copy, so basically we do mem copy pseudogram plus op size here, and then we go straight into, so yeah, that's what we do. That should do it. Start our SSH connection. List our available connections to steal. Find our SSH one, and let's go try to trace SSH now. Cool. Well, we got one packet and it dropped. We did compile our code, so we know we got our changes. This is TCP keep alive. Oh, send is equal to 0. There you go. Let's try this now. I'm sorry this is taking so long. This is just like a big pain in the butt to do. List. Who sees us? You think I would pipe to grep already? Fuck yeah! Single. Awesome. Woof. Cool. So I bet there's just a bug in my code somewhere. So I bet we send this and then we use sleep and then we'd like do it again or something, and like we're getting into a sig fault. Cool. So awesome. So here we did iter 0, we said sent packet TTL, and then iter 1, and then it exited, and then we ran it again, and we got a seg fault. And now we're seg faulting every time. So I'm wondering if we're not managing some error somewhere. Seg fault is related to buffer overflow. I doubt it. I wish, that'd be cool, but I doubt it. I bet it's related to my shitty C code. Proc entry. So this is trace. Where are you? Okay, cool. So we do tcpcon from inode. If PID is equal to 0, or we'll say tcpcon dot inode equals 0, right? What is this default to? So let's list. SSH here. Seg faults. Val grind time. No! I don't want to get a debugger out. I like to try to find these myself. It's part of the fun. Okay, so trace.c. Dang it. Benson knows about these floating around the source code, don't you, Benson? Cool. Debug is best debug. Cool, so let's find an L. Let's get another here. I'm just going to use this Brave. I'm just going to use one from my browser because I'm feeling lazy. There we go. So that one's sent. These are all sending to the browser fine. We need the SSH is the finicky one. So let's keep tinkering with SSH. List. Damn. So we're not even getting here. It's seg faulting in this TCP con from inode. If I'm not mistaken. Yeah. So this function is seg faulting. Mine are usually 4-letter words. Fuck. An F fuck. Proc net TCP. Proc entry from inode. I bet it's here. Really? Nothing here. Huh. It's not a buffer overflow, is it? Mm-hmm. What's the fscan doing? It's just reading proc. Huh. It's some stupid thing in C. It's always some stupid thing. Let's see. So we have our inode. Cool. So we got to A, we traced, and then did it kill our connection? It did. And so now the connection's closed and we run again. List. Oh, we have to start SSH again. Okay, so SSH is running. List our connections. I'm piping this to SSH. There we go. And then we -t. That's cool. So it's not stake faulting anymore. So I don't know what I fixed, but I fixed it. Apparently. It is, however, no longer... This keep alive doesn't seem to work for SSH. Who wants to look and see if we can do TCP keep alive SSH? Does TCP keep alive? Gotta love Eisenbugs. The real reason Benson is here is to watch me debug ridiculous once-in-a-lifetime bugs without any proper debugging tools. TCP keep alive, yes. I don't even know what the fuck this means. It's so fun. The keep alive option, let's do TCP IP keep alive. Over a TCP connection, the connections... Once the connection has entered the connected state, it will remain connected indefinitely. We'll close the connection as in some time period. TCP keep alive. Okay. Is an optional feature and if included must default to off. The keep alive packet contains no data. In an Ethernet network, this results in frames of immense size of... There are 3 parameters related to keep alive. Keep alive time. Okay. Most hosts that support TCP also support TCP keep alive. So I guess you have to have it enabled on the fucking SSH server. Each host or peer periodically sends a TCP packet to a peer which solicits a response. If a certain number of keep alives are sent and no response is received, then the host will terminate the connection from its end. Well, let's see. TCP, RFC, keep alive. God, I hate this. I just want to close this. How do I close this thing over here? I don't know. According to RFC 1122, should only be invoked. What is this? Communication layers. Is there a keep alive? No. It appears 31 times here. Let's keep grepping. Oh, keep dash alive, of course. So this is Wireshark. Might be relevant when TCP connections refuse to die. God damn it, what am I doing with my life? Final handshake, ACK. Idle stab forever. TCP timeout. connection slot. This is kernel code. Summary here. What is this? Bro. So do we need to put anything in the IP header here? IPv4. Check. Urgent pointer. Hack. Bin. Is it because of the sequence number? Is that why SSH is dropping our packet? Because we're using a random sequence number? I mean, it's SSH. You know that the internet has sufficiently debugged and hacked the shit out of this fucking protocol. Part of me thinks it's not SSH, but rather the kernel on Alice. Well, what would ever give you the idea that anything is wrong with that kernel back there? I built it myself, Benson. It's perfectly fine. There's nothing wrong with that kernel back there. It's handmade. Okay. Well, I mean, either way, we know that we can trace non-SSH things, and we can just file this as a bug. So we'll list again. I'm not being accusatory. I'm just mad about your packets. Okay, so let's try Brave. We'll grab a Brave inode. Okay. We'll trace Brave. So Brave did drop it at some point. Let's try another one. Here, 1Password. See, all of these are getting one packet and then it's dropping. Maybe what if I just did this? What if I did no? Where we're going, we don't need flags. So compile and run. Seg fault and seg. So you know what I bet happened here in the seg fault? Let's go to trace.c. How do we do a mem set? Mm-hmm. You may want to enable core dumps. Yeah, I am enjoying my... So this one, the connection closed. Let's see if we can't trigger another. There we go. So this one is sending fine. That sent all 32. Let's try this Brave. These are all tabs in my browser. So these are getting dropped really quickly. Let's try Discord, see what we get. Segfault, there we go. Can I recreate this? So fascinating. So fascinating that it's segfaults, and then you run it again and it works. There's got to be a race or it's something to read it from proc. Anyway, I digress. I'm actually going to wrap up and get out of here. I need to go upstairs and start cooking dinner for the family. So, we're going to save my code right now. And I'm going to wrap up. Saving work for the night. Still getting some mysterious seg faults. It's time for a proper debugger. Okay, so maybe we'll do GDB later. I'm getting exhausted, so I'm gonna wrap up. Git push origin main. If you want to see the blog with a lot of the work, it is here. And I'm sure I'll figure out more, and I'll keep streaming. So this is the whole thing that I want to tell folks is I am here to stream more. I'm going to try to maybe stream more around this time in the afternoons. This seems to work well with my work schedule. And so just in general, I am going to try to be more present here on Twitch. So thanks for sticking around, everyone. The capital S means sign. I sign all of my commits with my PGP key. So the capital S is sign. Minus S is sign off. So that's like add the little section to the end so that the CLA bot will accept it in the future. Null is not responsible. I feel you. So we're gonna raid Zunderscore. And I will see you all next time. So thanks for sticking around. I love you. I think you're beautiful people. Take care of yourself. Take a break. Get some water. I believe you're all remarkable, wonderful people. Period. So thank you for the follow, everyone. I am not currently on social media, so the closest thing you're going to get to social media from me is either here on Twitch or on my Discord, which you can join if somebody wants to run the Discord command in chat. We're going to go raid a buddy of mine. His name's Underscore. He's my favorite way to unwind after a busy day of using my brain. So please, please, please tell Zunderscore hi, and I will be watching Zunderscore right there along with you. I love you, and I'll see you next time. Have a good night, everyone.